Greetings. This is the first of a series of video clips on the subject of test design. Visualizing test designs for me is an important thing, and yet there doesn't seem to be any standard visualization technique. One tool I find very, very helpful is mind mapping. I urge you to take a look at the Mind Map book by Tony Buzan. Mind mapping is a structured way to organize your notes, and mind maps let you visualize objects and the relationships between them using illustrations and text. Many of my mind maps are just text organized and decomposed in different ways. As you learn more, you can sort of build mind maps with the knowledge you gain, shuffle them around. I find mind maps very handy in test design. So you'll see scattered in the different test design approaches from time to time, I will bring up and I'll use a mind map. Now you can also just do a lot of the mind mapping with outliners or with maybe list managers. But if you have a chance, take a look at the mind mapping tools and the mind mapping book by Tony Buzan. It's a great way to visualize the relationships between objects, and it comes in very handy for a lot of different test design techniques. So from here and there, I will be using mind maps. Before someone gets to test design, there should be a reason for a test design. I like to suggest on a project, it's important that we sort of have buy-in on certain terminology. What do we mean by things? Certain decisions. How are we going to sort of track and make certain decisions? And frankly, on aspects of testing. So what are we doing? What are we looking for? For the definitions, it's very important that we're in sync on what quality is. Almost all testing is learning about quality aspects of a software product, and therefore, what is quality? What does it mean to us? It is critical. Similarly, if we're looking for bugs, well, what constitutes a bug and what doesn't? And this is something that helps really scope a lot of our work. What type of bugs are we actually looking for? Of course, I think for the purpose of this course, we should have a broad definition. So a bug is any concern about the success of the project is an excellent broad definition for the purpose of training. However, in any technical software project, it's probably a very good idea to take a deep look at what type of bugs you care about and what type of bugs you don't care about. We don't have a lot of time, and this helps us focus. And the last thing is done, especially in agile projects. This jumps at you as very important, but any project, it's the same thing. What does it mean to be completed? If testing is learning about the quality of a product, when is it ready, what is it shippable, what is good enough? Any decision-making processes should exist before you start designing tests. We should know how people prioritize requirements, bugs, tests. So this is something that should happen before test design. And if we are doing testing on a project at different levels, it's important to say, what are the levels? Now, common things are to say that a level of testing is like unit testing, the testing done by programmers while they write the code is often called unit testing. There's a level of testing called integration testing, where you combine the work of 2 or more people and you integrate it. There's a type of testing called system testing, where you test transactions on a completely assembled system. There's a type of testing called acceptance testing, where the customer takes responsibility for verifying really that their acceptance criteria have been met, usually before payment is made, for example, for a custom software product. So this is the levels of testing. And what's in scope and out of scope for each level should be really decided before we start designing tests. Otherwise, we may dive in deep looking for things that don't really matter at a level. We may have covered it all at another level. There's no reason to be redundant across levels, at least not deliberately. Scope, what's in, what's out. What good enough, right? What's good enough, as I mentioned. When we're designing a test, we will usually have a reason to design a test. That means we will have something we want to learn about. These are called test objectives. What do we want to learn about? What is the test objective? We know that it has already been identified. So we're not just testing for fun. We have a test objective. There is a purpose for the testing to fulfill the test objective. It's important. We don't have time to work on test objectives that are unimportant, except perhaps when you're doing academic exercises, you know. However, in a commercial project, you'll want to make sure not only do you have a well-defined test objective, but it's an important one. And we have also knowledge about how to design a test for this particular piece of software. Either we have domain knowledge, we have requirement documentation, we have design documentation, we have access to subject matter expert, or we've just learned what we need to learn by studying the application. But we have some knowledge before we design a test, some knowledge about what we're testing. I'm a big fan of creating a diagram to help guide testing, but it doesn't have to be always a diagram. It could be a chart. Actually, Excel spreadsheets are fantastic for putting charts together or putting tables together of information. So when we create a test design, it's important to sort of have some sort of model that we've put together. I like to say it's a blueprint, which will help focus our work. And the blueprint or the diagram or the table, whatever we use to help design our tests, will be something that we can reuse over and over again. You're going to find in testing that test procedures are very expensive to reuse, but test designs are not. Test procedures are expensive because if you're making a slight change in a user interface, for example, you have to rewrite your procedures, but your test designs don't really change. So you can take the same test design and apply it to, for example, the web version of your application or the mobile version of your application, even though the test procedures for the two will be dramatically different. So the design becomes a reusable tool. This is why I ask people to draw a picture or visualize it somehow. Save that. That's going to be a useful thing. It's good evidence of what you did, and it's good for future reuse. Test design is also a collaboration tool. We can share our test design with our customers to make sure we're focusing on the right things, so the customer can use it with us to communicate about what's important. Programmers can use it to communicate with us about both areas of technical risk, areas of concern, completeness, that they can, if they're looking at our test design, understand where we're going in the testing, and they may be able to complement our test design. And also, my hope and my dream is all programmers learn some test design. So developers should not just be someone looking at other people's test design, they should be contributing themselves. And of course, testers working with other testers and working with their management. The test design is a fantastic collaboration tool. Share what we're doing. So that's just a nutshell of where we are when we start. Now, test design activities are, I guess, if you think, thinking exercises, problem-solving things. And the problem we solve is usually, how are we going to fulfill the test objective? How are we going to learn? The test objective comes from many, many, many different types of test ideas, all with different sort of purposes and reasons. So once we get to this point, we're at that point now. We said, okay, now I know, I know all that stuff. What do I do? What actual values am I going to type into what fields? What type of information am I going to program into my automated tests? What are we going to do? To start, I always like to start, and I urge people to start with what's called variable identification. First thing you do in test design, after you've got the test objective, you're all ready now. You got everything you know. It's an important thing. You have a clear test objective. You have subject matter experts available, all that stuff. What are the variables? Well, to vary is to change. To vary is to change. A variable is something which can change. A lot of programmers who learn about the test design, of course, they think, when they think of variables, they think of program variables. But in testing, it's a lot broader than just program variables. It's literally anything that can change. Now, the software behavior depends on the values of many variables. Anything which influences the behavior of the software could be a variable. So anything which influences the behavior of the software, or I could argue is influenced by the behavior of software, could be a variable. To find variables, there's a lot of different places to look for them. I keep going to my metaphor of the testers got to stick their nose everywhere to find out about these things, but sometimes it's common sense. Sometimes you just have to read the requirement document. So the source of information for variables, we call our test basis. Whatever it is, the test basis, it must exist, but what it is varies dramatically from project to project, even from test objective to test objective. I would say, it's pretty common to start with something like a requirement document or something like the statement of a user story. So we review the statement of the user story, we review the statement of the requirement, we review whatever information we have, and we try to identify variables in it. So when we're reviewing it, we're calling it, we're looking for variables, things that can change, that influence or are influenced by the behavior of the software. We're interested in variables relating to what influences the system, but also what are the variable outcomes, what is influenced by the system. And where do we get this information? Well, if we have business rules, there might be what are the conditions of the business rules? Those are input variables. Environmental factors, what is the environment? What the operating system, for example, the version of operating system is a variable. Rules is the relationship between conditions and options. Those could be variables. Constraints, there must be this much memory in the system. That might be a variable, or it indicates a variable, points to a variable. Actions, states, all sorts of things that can change in the system can be considered as variables. Now, my fictitious chocolate wrapping device that I always talk about when I'm doing exercises in test idea generation or test charter generation, the fictitious chocolate wrapping device is called the Wrap-O-Matic, right? And I'm going to basically suggest that the Wrap-O-Matic, it takes as input chocolates of different types on different conveyor belts. There's so many conveyor belts, so many different types of chocolates. There are papers that the Wrap-O-Matic wraps the chocolates with. Each belt, by the way, can have a different type of chocolates, although all the belts are operating at the same speed. And the chocolate, once they're wrapped, could be tied with a ribbon. If the chocolate doesn't fit the weight range detectors, it gets rejected. Otherwise, it gets placed into a different type of box. We have detailed requirement documents that describe the Wrap-O-Matic. We have all sorts of visualizations of what is the Wrap-O-Matic. But if I'm going to be testing the Wrap-O-Matic and I want to test the wrapping ability of the Wrap-O-Matic, I probably am concerned with identifying variables related to the ability of the Wrap-O-Matic to wrap chocolates. So the test objective might be confirm that the Wrap-O-Matic can wrap chocolates. So what are the variables? What are the factors that influence that? And this becomes a very interesting brainstorming session, if you will. It's an interesting thing because you can actually start by calling a basis. We have actually requirement documents. You can read through them. You can take a highlight marker and use yellow to highlight what are variables, and it'll make you think of things that are variables. So in terms of testing the capability of wrapping a chocolate, well, the variables culling through the requirement document, reviewing our sources, break into a few types. There's input variables, which are the types of chocolates. So we're wrapping different types of chocolates. There's types of paper, different types of paper. Paper is something we wrap a chocolate with. It's not necessarily made of paper. Different types of ribbon, different types of empty boxes, and something called a manifest. The manifest for the Wrap-O-Matic, the manifest, is actually a description of a production run. How many boxes of chocolate of this type? Where are the chocolates in the box? This chocolate is at that position, etc. So that's called a manifest. So each production run has a manifest, and the manifest tells the Wrap-O-Matic where to put the chocolates in the empty boxes, what type of paper to put on the chocolates, what type of ribbons to put on the chocolates, and which belt has which type of chocolates associated with it. So this is basically input variables. Now, of course, chocolates themselves vary. There's a lot of variations in chocolates. The elements that are very important for the wrapping logic of the Wrap-O-Matic are the composition of the chocolate. What is it made of? The configuration of the chocolate. What does it look like? The viscosity of the chocolate. What is it viscous or is it dense or liquid? The weight of the chocolate matters, the size of the chocolate matters, and the pattern that the chocolate arrives at, the input stream. It's a little bit like a transactional system. The arrival rate and the arrival pattern of transactions is actually a variable. Composition, well, we have a fixed list of chocolates that we support. So we support milk chocolate, dark chocolate, fudge, hard candy, white, bitter, semi-sweet, Swiss, and Belgian chocolates. And it's interesting to note that fudge, hard candy are not really types of chocolate, but because they are things the Rap-O-Matic can wrap, we count them in there with the list of chocolates. So that's the type of chocolates that the Rap-O-Matic can wrap. It's a specific list. There's configuration. So how does the chocolate configured? The truffle is, for example, a European style hand-rolled type of chocolate. They call them truffles. It's not the truffle the pig is chasing. This is the truffle that's the candy. There's praline, which is a type of filled chocolate, very popular again in European chocolate factories. And I've toured a lot of European chocolate factories, so I tend to look into these things. Bar, a bar is a common way people in North America like to partake in chocolate, although actually it's also in the United Kingdom. Cadbury, for example, champions all sorts of different bars to eat chocolates as a snack. Probably too much, cholesterol and all that for me, but still, that's a configuration. Then there's a traditional chocolate. Those are the ones that you'd find in a box of chocolates, like Laura Secord, for example, in Montreal, has boxes of chocolates. A turtle, which is a type of chocolate with the pecans that look a little bit like a turtle. I'm sure you've seen these. That's a style of chocolate. It's a very weird configuration of chocolate. Some people around the world, when I describe it to them, they say, ugh, it sounds like you want to eat turtles. But it's not. It's just a chocolate thing about the shape of a turtle. There's bonbon chocolates, which is sort of like a French wrapped chocolate, and a filled chocolate, which is some sort of praline, but you stuff it in a different way. So there we go. Those are the configurations the Rap-O-Matic supports. And then there's the viscosity. So the chocolate could be solid, hollow, jelly, or semi-solid. So these are the different viscosities that the Rap-O-Matic can handle. There's weights. Now, the weight for a chocolate could be too light, too heavy, or in range. Of course, the exact numeric value for the weight probably depends on the type of chocolate. So we have to knowledge that Rap-O-Matic somehow knows how to say, well, this type of chocolate should weigh no more than this, or that type of chocolate should weigh no less than that. They have ranges of weights for the types of chocolates. Chocolates vary also in size. So the Rap-O-Matic has, size. We call them 1, 2, and 3. But basically, size 1 would be a very large chocolate. Size 2 would be a typical normal chocolate that you get in a box of chocolates at the drugstore or the pharmacy. And size 3 would be like a miniature chocolate, like you'd see at Valentine's Day, little miniature chocolates that are very popular. Other variables, we talked about the conveyor speed. Well, the conveyor speed of the Rap-O-Matic can go slow, medium, high, or very fast. So that's the conveyor speed. All of them in harmony, by the way, all of them in sync, but at different speeds. And that's interesting, the speed of the conveyor belt. It's interesting that it might be faster than the processing speed of the Rap-O-Matic. So you have interesting possible boundary issues there in terms of the speed. However, the Rap-O-Matic will tell the conveyor belt to slow down if it's going too fast. It'll pause it. It won't change the speed of it. It's like pausing it and telling it to go. Stop, go, stop, go, stop, go. That sort of control. The distribution of chocolates, so this is now the arrangement, the distribution of chocolates in the conveyor belts could be regular or random. So the regular would mean that the inter-chocolate gap is uniform, and random would mean that it's totally arbitrary. It is truly random. So this is the distribution of chocolates on the conveyor belts, and the frequency is basically the measure of chocolates per, like the density, chocolates per unit of length, and they could be dense or it could be sparse. So sparse would be a low amount of chocolates per unit of length, and dense would be high. And that's the input variables related to the input stream. Paper, the Rap-O-Matic supports basically 5 types of paper, one being no paper, and then thin wax, foil, and tissue. Now, none here is a valid input here. There's none, paper saying none, that's deliberate. But it's also possible we accidentally have none because we run out. So this none thing is a very tricky thing. So paper can be none, thick, wax, foil, or tissue. Similarly, ribbons can be none, could be none deliberately or could be none accidentally. Thread, string, cord, wire, those are the different types of ribbons. So we have interesting things, different types of chocolates, different types of paper, different types of ribbons. We have empty boxes that I'm sure that you've been to chocolate stores. You see all these cool empty boxes that vary by type, size, and configuration. The type of boxes could be rectangular, circular, heart-shaped, common at Valentine's Day, or custom boxes that might be there for charities, OEM custom boxes. And also popular these days are bags. In fact, Lindor Chocolates puts the chocolates sometimes in a bag instead of a box. So a bag is actually a type of box. It's a container in which they're shipping the chocolates. The boxes can vary in size. So we have small, medium, large. Those are sizes of boxes. And for the boxes, there's configuration, single or multiple layer boxes. So this is the box characteristics, type, size, and configuration. So you have just, those are variables. Imagine another case here, so variable identification. Imagine you're sending an email via Gmail with an image attachment, and you're on a testing team. You've just added the feature of sending an email with an image attachment. That's a brand new feature. It's out there on the market. Everybody loves it. Okay, so you have to test the capability. Your test objective is to do confirming that we can actually send an email with an image attachment. So what are the variables related to sending an email with an image attachment? Well, in fact, you can take a look at someone using Gmail or a similar tool, but Gmail in this case is the one we looked at. And you can sort of say, okay, what variables are there by watching people that may relate to sending images with attachments? And they could be things like environment variable. So what resources are being used, memory, CPU, disk space, stuff like that. What software is being used? What operating system and browser versions are we using? How are we connected to the internet? What type and bandwidth and capacity do we have for that connection? Then when you look at Gmail, to get to actually sending an email with an image attachment, there's credentials related to login. So there's, first is the URL. How do you get to the login page? Do you type www.gmail.com, or do you type some other weird link to get there? There's your credentials, username and password. Those are variables. Inbox. Once you're doing this test to try to send emails with image attachment, you realize the state of the inbox probably has a lot to do with the processing. And the inbox state has things like the total number of emails, the total number as a percentage, the number of received emails, number of copies. I'm not sure what that exactly refers to. I think it's copies of emails, duplicates of it. Emails per page, memory used versus memory available on the server side. And then the composition of the email has variables. There's the toString, the CC string, the BCC string, the body of the text, the attachments, the subject, the date of the email. And if you dive in, you can look also at things like, in this case, searching. When I was studying someone using Gmail, it was made evident that Gmail was a search engine tool. And so what about searching characteristics? Or there's time characteristics. Maybe there's time delays that are taking place. And what about GUI? There was actually GUI elements that come up, like pop-up images of the image with scrolling or not scrolling. So do we have scrolling or not might depend on the image. And for the image itself, there's the type of image, size of image, resolution of image. All these type of things are also variables. So we have one way to identify variables is to basically like watch someone doing watch someone doing a transaction and study what can change related to it. In fact, for the Gmail case, I've done a lot of work with that one, and I've actually got some statistics on that. It works out that the average person who's an experienced tester finds about 23 variables when they study someone sending an email with an image attachment. The record of them is over 100 variables identified by a single tester. This was in Melbourne, Australia, very competitive tester. and they basically identified a lot of variables. Now, of course, I want you only really to find variables that are relevant and in scope to your objective. So this person was picking a lot of things that might not have been in scope for other people, but still over 100. And when I studied many people, I went to England and I took 50 people and I had them identify variables for the Gmail image attachment. And I found out that the aggregate number of variables we identified with a group of 50 people was actually 141 variables. So between 50 people, we identified a heck of a lot of variables. Now, are they all variables that we want to muck with? I don't know, but I want to choose variables that are relevant and in scope, and then I'll decide how I'm going to deal with them, and then I'm going to start to choose values for them. But first, we got to identify them. This is an example from an insurance policy from a major American insurance company, and the test here was, the objective of the test was to say, can we cancel a policy? So confirm that we can cancel a policy. The customer needs the policy canceled, confirm we can cancel the policy. And so that's an interesting piece of business logic to test. And by looking at it, they ran into all sorts of variables related to the source of the policy, the reason for the cancellation, the method for the cancellation, something that they call lines of business, decision-related variables, date-related variables, print-related variables, policy-related variables, initiator-related variables. There's all manners of things that are tied to the insurance industry that are related to canceling a policy. And if you want to test, confirm that we can cancel policy, we have to be sensitive to these variables. And once you start looking at this, is just mind maps of variables, you'll start seeing that once you've got a visualization of the variables, the visualization, you can share it with other people. You could take your mind map, if you will, if you do it this way, and show it to a programmer on the team, or show it to another tester on the team, or show it to a product manager on the team, and they will walk through it with you, and they will be able to guide you and also point out variables that are missing or variables that might not be relevant to the application that you're testing. So I like to use the visualization in a mind map to help gather information and insights from different people. But when it comes down to it, once you've got a nice, healthy list of variables, there's really only 4 things that you can do with a variable. So what I like to do is I like to say, okay, now that I've got my map of variables, and I'm convinced that these are variables that influence or are influenced by the behavior of the system, they're variables that may be of interest in a different context, I want to make a choice then, what do I do with the variable? The 4 things I can do with the variable. First thing, I can ignore the variable. I can deliberately ignore the variable. We see this in electrical engineering. If you ever do circuit analysis, we do equivalent circuits, and we basically do things like saying, let's look at a circuit here, and we will ignore the DC characteristics, and we'll study it. Or let's look at the circuit, and we'll ignore the AC. AC stands for alternating current, DC direct current. Or we might say, let's take this circuit, and we're going to ignore high frequency impacts on the circuit. So all of those help you model a problem better. So we're deliberately ignoring things. In software testing, when we look at our variable map, the first thing you want to do is say, what variables do we ignore? Now, these variables, by ignoring them, we are not going to deliberately set them, change them, or otherwise manipulate them. Now, we may find a bug related to them, but it's not going to be because of the intent of the test. It's going to be because once we found a problem, we isolated it to that variable. So these variables may show up again to us while we're working with the system, but we're not going to be deliberately setting them to anything. It is really ignored. It's ignored on purpose. We're deliberately ignoring it. It's not ignored because we forgot about it. It's not ignored because it's something that is frivolous. We're ignoring it because we're making a conscious decision of what's in scope and what's out of scope. And this is, of course, your prerogative as a tester of a system, which variables matter for you to meet your objectives. And you may have to, again, deal with other people, programmers, architects, business stakeholders, to make sure that you're on track with this. First thing, ignore. Second thing, you may want, for a lot of variables, to, instead of manipulating them, to set them to some sort of default state. So setting the variables to a default state is a very, very good idea for a lot of the variables that you've identified. What is the default value? This is a testing question. What is the default value for the purpose of testing? Well, some teams set up examples and say, okay, this is the default. We will have, for an insurance policy, here's the default set of variables. Now, if you're not going to manipulate the variable, you can choose to leave it at the default state. And many companies choose to make the default state the most common state, the most typical state, the most likely state. So that means you exercise the more common values for all sorts of variables while you're doing your normal testing. So that would be one way to look at it. Another way to look at defaults is saying, let's pick, for the variables that we're not going to be manipulating, let's pick the harshest conditions we can imagine, so that we're making the application work harder and harder and harder. So we're always taking the harshest values. It is really up to your team to decide what is the set of default values. Usually you name them. This is our harsh set, this is our typical set. And once you say that, you might have 50 or 100 variables that you know exactly what values going to go in there, and you don't have to think about it. Just say, this is the default value for this bunch of variables. A common way to do this is security. If you look at security on web browsers, you might see that there's dozens, if not hundreds, of options. It's ridiculous in a test design to basically go and say explicitly what all the different options are, but you might say, no, we're going to leave the default security level 2. And then everybody knows that that's a set of variables that are going to be all set to specific values. So that's a default setting. So first thing you can do, ignore. But deliberately ignore on purpose. We don't care about this variable. It may show up in bug isolation, but we're not deliberately going to be investigating it. Second thing, default values. For values that we're not going to manipulate, we can set prescribed values on them. So every test we're going to do on Windows 10. So that's the default operating system. So that answers a lot of questions about operating systems. That's a default. Specific values. The third thing we can do, for a variable, we can choose specific values. And that's, of course, what now the other test design techniques are going to share. How do we choose those values? Well, we want values that are going to exercise the application to help us fulfill the test objective. So we can't test everything. We've got to find a subset. Test design is about focusing on a subset. So the specific values we're looking for are a subset of all the possible values that'll help us learn about the test objective. The fourth thing we can do with the variable, and it can be combined with the other three, is to observe. So some variables are variables that you're going to watch. One of my favorite ones to observe is CPU saturation. So while the application is running, while everything is going on, the CPU, percentage CPU usage is something I'm going to watch. Now, I'm not going to be manipulating it directly, but I'm going to watch it. And what I want to find out is, do we ever saturate the CPU? Do we ever exceed something like 80% capacity? This is something that's going to be a very interesting thing for me to study. I also like to watch the amount of free memory while I'm working. So just watch it, study it. I'm not going to deliberately manipulate it, but I'm going to watch it to see the dynamic characteristics of the software as it's running. So these are the four things we can do with the variable. And to summarize, what I'd like to do is basically identify from the basis we have, whatever they are, people, documents, whatever, identify variables, try to brainstorm and get other people involved, make sure I've got a nice list of variables related to the test objective. And then once I've got that set of variables, I want to go through them and see which ones can I ignore. Hopefully I can get rid of a whole bunch of them that way. Which ones I'm going to set to the default, get rid of a whole bunch of them that way. And then for the few that are left, and we're usually talking between 5 and 10 variables here, we're not talking thousands, maybe even 1 or 2. Those then we're going to come up with strategies to find specific values for them and manipulate them in our testing. So that's it. So thank you very much.